Hey everybody, this is 11-2 Constructing Scatter Plots. We have Jared's basketball team that they stood at various distances from the basketball goal and counted the number of baskets they were able to make in 30 seconds. The distance each person stood from the goal and the number of baskets made is shown in the table below. So I have, because I don't want this lesson to be like an hour long, I went ahead and plotted the points. So if you want to stop the video so you can plot your points, please do so. What we should think about is if the closer to the basketball goal that we are, do we think we're going to make more baskets or less baskets? Okay. Obviously, we should be making more baskets. So as the distance from the goal gets further away, we would expect that the baskets made would be less. So we would think that we would probably have a negative association. Now, if you look at the points that I already plotted, you may look at it and say, well, that doesn't look exactly negative to me. Well, we also see some other observations that we can see is that there seems to be a point that doesn't fit with the rest of the groups, and that would be that one out here. Okay. We might always also see that there are two distinct clusters of data. So we've got this cluster of data up here, and we have this cluster of data over here. If we look at the different clusters of data, what we can see is that the first cluster is around 15 feet from the goal, 15, 16 feet from the goal. There's pretty high amount of baskets made. The second cluster is further away from the goal and less points made. Okay, so that's kind of what we're seeing there. So we're going to answer these questions down here. As the distance from the goal increases, the number of baskets made decreases. Absolutely. So again, you're looking at this first grouping up here compared to this second grouping right here. If you look at them, the further they get away from the goal, the number of baskets made decreases. Part B, as the distance from the goal decreases, the number of baskets made increase. Yeah, as you're going along this x-axis, the more you go this direction, you can see that the more baskets that you're making. So that is also true. It's just saying A in reverse. C says, as the distance from the goal decreases, the number of baskets made decreases, and that is a false statement. Okay. At a point that does not fit the overall pattern or trend of a scatter plot is known as an outlier. We've got that going on with that one little dot right there. Okay, who was the outlier? Well, that coordinate, if I'm looking at it correctly, is 14 feet from the goal, 4 baskets made. And if I look up at the data, who fits that? 14 for X and 4 for Y. That's Jared. Okay, so who is our outlier? Jared. Okay. The number of baskets made was much lower than his teammates. At the same distance, but I don't have room to write that. Okay. We also have clustering that's happened in this graph. Clustering occurs in a scatter plot when the district or separate groups of points Okay, so we have clustering over here. We have that cluster of 1 and cluster of 2, big gap in between. Why do you think the clustering occurred in the scatter plot below? It looks like we had group 1 players stood closer to the goal than the group 2. let's go ahead and look at number 3. Okay. I also did the points again here. I'm hoping that you will go ahead and look at them. I do want to show you a Lawton. Lawton is at 76,000. Number of elementary schools is 19. So this is a population of 10 cities and the numbers of elementary schools it has shown in the table. Okay. So you can see that the population is in thousands. So you don't see 76,000 down there, but you see 70 and you see 90 in 19 elementary schools. So 76,000, 19 elementary schools, we're going to do that as 76, comma, 19. So when I look at my x-axis, okay, oh, and here's another thing. What the data that's given to you first is x, your independent variable, and the data given to you second is y. So go ahead and label your x and y axes. Okay, so 76,000, comma, 19. Well, I can see that my graph is counting by tens. So this little point right here is actually 80,000. So 76 is going to be about right there. And then 19 would be about right here, that purple dot up there. Okay. So go ahead and practice plotting those points. Pause the video and come back when you're done. Okay. So welcome back. When you're looking at the association between the variables, you would assume that the higher your population, the more schools that you're going to need. So that's going to be a positive association. We can tell by our graph that is true. Okay, so as population increases, number of elementary schools should also increase. I'm abbreviating. Okay. Are there any outliers in the data? Well, yeah, this one right here would be an outlier. So I'm going to say yes, and that point is, let's see, 20,000, comma, 20. So 20,000, comma, 20 would be right here. That would be Glens Falls. Okay, and Glens Falls is much higher than the pattern of the data. Okay, do we have any clustering? Do we have any distinct groups like we did up here? Okay, so no, I don't see any of that. So there's no gaps or groupings. Oops. Okay. All right, so let's take a look at the last one. Now, I didn't do the dots there because I want us to practice them together, but there's not as many as there were in the other problems. So on Tuesday after school, Charlie asked 9 different students how much money they had in their lunch account, as well as how many homework assignments they had that evening. Use the data that he collected to make a scatter plot. So there's all of our data. We can look at our X values as the amount in the lunch account, homework assignments here. First of all, what do you think is going to happen? Do we have any correlation between the two? The amount of the amount of money you have in your lunch account, do you think that's going to determine how many homework assignments you get? Probably not. Let's see if that works out. All right, so our lunch account is counting by $5, and our homework is counting by 1s. Okay, so that works out. Lunch account for the first person is $8.24. That's going to be somewhere between $5 and $10. 0 homework assignments. I'm going to say it's about right in the middle there. Okay, $29.05 for the second person with 2 homework assignments. So I'm going to go all the way to about $29.05 would be all the way down at the x-axis up to assignments right here. $4.75, 1 assignment, about right there. $20.01 and 0 assignments right there. $1.80, 3 assignments, about right there. Let's see, $11.92, we're right at $12, and 4 assignments there. And then let's see, $0, one assignment, and $17.50. Oh, sorry, my TV just came on. Oh, sorry about that. Okay, $17.50 and two assignments. Okay, and then the last one, $26.11 and three assignments. Okay, so as you can tell, those points are pretty much all over the place. So describe the association between the variables. There's none. Okay, amount of money you have in your account. Does not affect the number of assignments that you have. And I should say has no effect, probably using some proper grammar. Has no effect on number of prep work assignments. Okay. Are there any outliers? Well, if we don't have any association, we don't really have any outliers either. So, no. The scatter plot has no pattern. Okay. And then the last one, is there any clustering? No. The scatter plot has no pattern. Or no distinct groups, I guess I should say. All right, that's it, guys. Have fun with your prep work.